This conference will now be recorded.
Yes, guys. So in our last session, we learned about how to create double linked list. I hope everyone remember, and how to insert a node in the double linked list at the beginning position. That also we discussed in our last session, right? Today we will see how to insert a node at the end of double linked list and in any position, like our single linked list. Same approach we are going to follow here. So what is the case 2? Case 2 will be insert at end. I already asked you people to practice that SLL insert at end and insert at any position for much more better clarity. Very easily you will understand them, because as I said, 90% will be similar. So this is the case. Mostly I will go for copy paste. 3, 4. Before that, 3, 4. Number 2. Create linked list by create this time double linked list by insertion at end. Okay, so it will be coming under the case 2. It will be coming under the case 2. This is case 2, guys. Enter the item to be insert, everything okay. Here it will be DLL insert at end. Now I will copy the function. On there I will make the change. I hope in the meantime all of you have practiced that single linked list related all the application whatever we have developed. If we get time, we will go for few more application in future, right? Okay, next, this is insertion at end. DLL insert at begin, DLL insert at end. Okay, next, and after that, where we need to make the changes, sir? In double linked list insertion at end, observe carefully. Let us assume double linked list insert at end. Double linked list insert at end. Suppose for example, we already have a double linked list of few nodes. Let us assume 4 nodes. One, 2, 3, 4, 5. The 5 nodes are there. So how they are connected? From here, this one, guys. Remember, from here to here, not in the inside it, outside it. It will point to the node, not inside the node. While giving the arrow, have to be very careful. Coming from inside, but pointing the other node, not the inside of the node. Don't enter the arrow like this. It's a different meaning. No, up to here. Up to here. This is the front end. Parallel to this, we are having one more, that is from here to here. This time from here to, yes, outside, not inside. Okay, what we are having here, last node link part null, first node prep part, null. Okay, next, who is pointing to the first node? Start is pointing to the first node. Start is pointing to the first node. This is the start. Okay, na? Some values are there. We are least interested about the values. Any value, 10, 5, not necessarily sorted order, some values, any order, 20, 25, say 30. Like this, some numbers are there. Now, what I will do here, once my program will run, execute, compile, and run. Definitely, I will give the option number 2. But when you give the option number 2, sir, at that time no node is there, na? That means start where is pointing start. Start is pointing null. Control came to this function. One node definitely got created. If part not executed, in that node, item and null value are there. Item is inserted. Link part is given null. Only link part is giving null will be enough? No. Once I give the choice, what is the first activity? This function called. Step by step, let me draw. First, this line will execute. Once this line will execute, as per this line, what to happen? Sir, one node will be created. See guys, insertion at end, this we can divide it into 3 different cases. What are the 3 different cases? Case 1. One case can be no node in the double linked list. Currently, I am discussing about this case. No node in the double linked list. No node is there. This is my first case. Currently, we are analyzing this one. Case 1. No node in the linked list. No node is there in the double linked list. So as per that, what happens, sir? First line executed. Who is holding this address of this node now? Temp. Temp is holding the address of this node. Super. Now, is temp is null? No. Control comes here. Temp arrow data is equal to item. Some item value, guys, we are least interested about that. Some value, let it be 35 or anything. Some value, 10. Okay, next. Sir, this is insert at end, na? So link part will always have the null. Last node link part will always have the null value. Let me give that. Let me give that null. Next. If start is null, yes sir, start is null. Start is null. Then what to do? Are you going to write start arrow temp? Start is equal to temp. This is used to write for single linked list. Here, when start is null, now you need to make 2 pointer adjustment. What are the 2 pointer adjustment? One is this fellow I need, and another is start fellow I need. These 2 fellow I need. When it is single linked list, sir, after giving the null, only start is there, enough. Only start is there, enough. Am I audible, guys? Confirm me once. Is my screen is visible, students? Yeah. Okay. Now, if it is single linked list, very easy, sir. Just start is equal to temp is enough. No. Double linked list. This point also you have to make adjust. This point you also need to make adjust. Very simple, sir. What you will do? Before making start is equal to temp, it will always be there. Start is equal to temp will be there. No doubt about that. But along with one fellow will come. Who is that fellow? You should tell me the code. You should tell me the code. I need to access this part. What to write? Very simple, na guys. Sir, temp arrow prev and give a null value to here. Do that. Temp arrow prev is equal to null. That's it. First time only, na, else part will not execute. Followed by start is equal to temp. Do that. First here null, and then start is equal to temp min. Start will come here and point to this node. Start will come here and point to this node. This is the case when you are having no node in the linked list. Sometimes it may happen you are already having some nodes. Sometimes it may happen you are already having some nodes. Maybe you use the approach 1, insert at beginning few times. So by that you created some nodes, and now you are taking number 2, case 2. What is that? Linked list contains some node. Linked list already contains some nodes, and I have to insert where? At the end. So how many nodes are there? Some nodes, guys. No need to worry that much. Some nodes. Suppose, for example, 5 nodes are there. 5 nodes are there. Now what we will do, sir? Again, algorithm will be called. Suppose, for example, close everything. Execute, compile, and run. Let us assume you are giving choice number 1, guys. That is insertion at begin for 5 times. You have given that. Choice number 1 you have given for 5 times. Let me do that. 1, 10, 1, 5, 1, 20, 1, 25, 1, 30. Display. Acha, this is insert at begin, na? Let me do one thing. Let me do in this fashion. One more time. Execute, Compile and run. I will give option number 1 only. How many times? 5 times. First time 30, 25, 20, 5, 10. Display. See this? 10, 5, 20, 25, 30. This is the linked list currently we are having. Now I want to give option number 2. Enter your choice. Immediately what will happen, sir? Case 2 will be executed, na sir? Yes. Control will come to this function. First activity, allocate a new node. Let's do this. Allocation of new node. This is my new node, guys. Who is pointing to this node, guys? Temp, sir. Temp is pointing to this node. Super. Temp is pointing to this node. Move further. This is not working. Temp arrow data is equal to item, sir. Temp arrow link null. Yes. Some value, guys. Say 35. Temp arrow data is equal to item. Temp arrow link is equal to null. Last node, na sir. It will always be the last node. The link part will always be the null. Null, null, null. Yes, null. Next. As per the coding, if start is null, check it out. Is your start a null? Is your start a null? No way, sir. Start is not null. Means, sir, if part will not work. Super. What will happen? Control will come to the else part. In the else part, what we have done here? PTR is equal to start. PTR is equal to start. Let's do that. Sir, I need to take a pointer here, which is named as PTR. PTR is equal to start. Next. While PTR arrow link not is equal to null. See this? PTR arrow link means the black one. Blues are priv, blacks are link. Is PTR arrow link is not equal to null? Yes. What to do? Sir, move the PTR. Good. Sir, loop will rotate again. PTR arrow link not is equal to null? Yes. What to do? Move the PTR. PTR arrow link not is equal to null? Yes. Move the PTR. PTR arrow link not is equal to null? Yes. Move the PTR. PTR arrow link, guys. PTR arrow link. Is it not equal to null anymore? No, sir. Then, sir, PTR arrow link is equal to null now. PTR arrow link is equal to null now. So you reach to the last node. You reach to the last node. Sir, story also I can think like end. Why? Sir, just I need to make 2 pointer adjustment. One from here to here, another from here to here. 1 minute. One from here to here. One from here to here, another from here to here. Then only story will be end. Connection will be done. This node will be added at the as the last node. Yes. Then what code to write? Sir, first I want to add, I want to touch this part. I will touch this part. Sir, PTR arrow link. Currently having what value? Null. I don't want to keep null anymore. What you write? PTR arrow link is equal to temp. What will happen, sir? Sir, from here, one connection will be created. Remember, not inside, guys, but outside. If it is single linked list, here it ends, na guys. If it is single linked list, here it ends. That's why I said that 95% are similar. But it's not single linked list, sir. I need to make another pointer adjustment. What to write for that? Sir, I will touch this part. This part means temp arrow prev. What to write? Temp arrow prev is equal to, where it will point, guys? Temp arrow prev, where it will point? Where it will point? Sir, it will point to the node that is pointed by PTR. You are touching, okay na? Temp arrow prev is going inside or outside, guys? Inside, sir. Sorry. Where it is, sir? Outside, sir. Okay na? Node added at the end, guys. What to write? Temp arrow prev is equal to, how many changes you have made here? One line, two line. Story ends, recompile, execute. Execute, sir, compile and run. What I want to do? I want to create a linked list which is already created by insert at begin. Let us assume, means some nodes are there. Enter your choice: 1, 30, 25, 20, 5, 10, display. One minute, guys. Yeah, perfectly displaying 10, 5, 20, 25, 30. Now, sir, I want to give choice number 2. Enter the linked list by adding a node at the end. 2. Enter the item to be insert. 35. Go for a display. Okay now, guys. 10, 5, 20, 25, 30, 35. Easy now, boss. That's why we spend that much time for a single linked list. Now everything is a variation even file. Sir, once single linked list is done properly, now everything will become very, very easy. Just a little bit variation, understanding properly, we have implemented. Double linked list, insert at end, guys. DLL insert at end. So insert at begin, insert at end is done. What is the third one, guys? Sir, insertion at any position. No problem. Again, first copy that print statement. What is this? Sir, insert at any position. That means this time we will take two things. What are the two things? Item and position. TLL insert at any. Now next activity is what? Copy the function. Or instead of copy the function, let us define it from the beginning. Just take one line I want to copy. Okay. Now it may happen that when the menu will appear, user can give this option as the first time. So whatever, sir, whenever user will give, the first activity is not going to change. What is the first activity? Memory creation and checking the temp value. This value will always be common, sir. Of course, for the insertion cases, not for deletion cases. Don't think for deletion also you will allocate memory. Guys. Yeah. So node creation is done, sir. Next and after that, what we are going to do? Suppose, for example, let me copy this one. So let us assume I have a linked list, guys. I have a linked list. Here, I want to insert at any position. I want to insert at any position. Then who will give me the position, sir? User will give me the position. I ask user, in which position you are expecting me to insert? User said, I asked what item? User said 40. 40 I'm expecting, and I'm expecting 40 to be inserted at position number 4. Okay, that means where actually? First position, second position, third position, fourth position. Oh, that means after 20, na sir? That will be the position of 40. That should be the position of 40 because that is the position number 4. So after 20 I have to insert. After 20 I have to insert. First activity is what? Memory allocation. Have you done that? Yes, sir, I have done that. Memory allocation part I have already done it, sir. Okay, very good. Who is pointing your node? Temp, sir. Who is pointing your new node? Temp. Temp fellow is pointing. This is my temp, sir. Super. Now, what to do? Sir, if I have to insert this node after 20, na sir? If I have to insert this node after 20, First activity that definitely I need to do here after this checking, temp arrow data is equal to item. This part will definitely be there, sir. Temp arrow data is equal to item. Super. What is the item? You said 40, na? So 40. Next, what I need to do, guys? Sir, if you are inserting it after 20, you have to come up to 20. You have to come up to 20. Then only you can insert. Currently, you are standing at start. Currently, you are standing at start, sir. Standing at start, you cannot insert 40. Why? Sir, how you will insert standing at start, sir? You have to come here na, to this node, sir. Then only you can think about insertion of this fellow. If you are not coming here, how can you insert this fellow, sir? So I need to come here, na? Yes. Currently, where I am? Here. So how many movement I need? One movement, two movement. Is it always? No, 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 sir. Suppose if anyone give the position 5, na, sir. If anyone gives the position 5, this 40 fellow will be inserted after 25, sir. In that case, you have to come one movement, two movement, three movement. Oh, it's not always two movement, na? Yeah. So it depends, na? Yes. So can you make a generalization? Yes. Sir, whatever position you will ask me, na, I will subtract it 2 times of that. That many number of movements. Really? Huh, sir? 4 means one movement, two movements. 5 means one movement, two movement, three movement. 6 means one movement, two movement, three movement, four movement. Super. Doing any activity repeatedly means you know that was. What is that? Sir, for loop will come into the picture. But before that, sir, when you make the movement, na, sir, you cannot move the start pointer, sir. Then your linked list will be lost. So what is the suggestion, guys? Sir, take a pointer with a different name, move with that pointer. Okay. Let me take the name of the pointer as PTR. So for this PTR, how many movement you are expecting? 2 movements, sir. Write the code. Why you are waiting? For I is equal to 1, I less or equal to POS minus 2, I plus plus. Sir, what is this I? Int I. In this code, what logic you are going to write? Sir, before that, make sure PTR is pointing to start. Super. Here, what you are going to write? Sir, want to make the movement of PTR. Then PTR is equal to PTR arrow link. PTR is equal to PTR arrow link. See, guys, as far the coding is concerned, POS value is what? 4. 4 minus 2 is what? 2. How many times loop will executed? 2 times. If the loop is executed 2 times, you know that. Sir, first time PTR is equal to PTR arrow link. Where is PTR, guys? Here. Sir, next time PTR is equal to PTR arrow link. Where is PTR, guys? Here. Super. Now, sir, I need this fellow. I need this fellow. The black fellow, sir. I need this black fellow. Not to point to 25, but to point to 40. Not to point to 25, but to point to 30. And I want the blue fellow. I want the blue fellow not to point to 20, but to point to 30. Super. But before that, how many pointer I need to make adjustment? How many pointer I need to make adjustment? Sir, this one will come here. One will be coming here 2. One will be coming here 3. Another will be coming here 4. 4 pointer adjustment is needed. Sometimes they ask for a double linked list for insertion of a new node, how many pointer adjustment will be needed? 4. 4. So from where we will start? We will start from our node. We will start from our node. What is our node? Temp arrow link. What is this portion, guys? What is this portion? Temp arrow link. What is this portion, guys? Temp arrow prev. What is this portion, guys? Temp arrow data. So first, where you will put your hand? Here. Why? Why not here? Sir, first if you update the black one, na sir, the connection with this linked list will be lost. Sir, blue is pointing, blue is pointing me, but I am not pointing to anywhere. So this connection will be lost na. Observe carefully, guys. If you update the black fellow, guys, what will happen? Sir, the black fellow will not anymore point to 25. Automatically, this portion will be lost na, boss. This portion will be lost na. Ah, sir, blue is still pointing. Someone, not only someone, n number of person can point to me. If I am not pointing out to anyone, that's basically meaningless, na. So if the black is updated, this connection will be lost, na, sir. Yes. So what is the first activity? First activity is capture this portion of the linked list. How can I capture? Sir, I have to put the address. Whose address? This fellow's address. Whose address? Sir, this node's address. This node's address currently is known to whom? To this fellow. To this fellow. Take it from here and put it here. Take it from here and put it here. Where to put? Here. To put it here, what to write, guys? Temp arrow link. Let's do up to this. To put, what to do, sir? Temp arrow link is equal to. What thing you will put? Sir, this node's address. This node's address currently where? Sir, to this black fellow. What is this black fellow? Sir, PTR arrow link. Take it from PTR arrow link and give it to temp arrow link. Take it from PTR arrow link and give it to take it from PTR arrow link and give it to temp arrow link. Temp arrow link is equal to PTR arrow link. Sir, immediately what will happen? You know, sir, this node will start pointing to this node. Will start pointing to this node. Super. Next. Sir, this blue one, sir, blue one should point to this one. This one means this node, sir, this node. This node means here or this to this node. The blue fellow should point to here or to this node. No, sir, to this node. To this node means who is having this node's address? Temp is having this node's address. But how will capture this blue one, guys? This one you can capture. PTR arrow prev. This one you can capture. PTR arrow link. How to capture blue one? Sir, very simple. Who is pointing this node? PTR. Tell me, guys, who is pointing this node? What is the name of that black one, guys? What is the name of that black one? What is the name of that black pointer? Who is pointing to 25? What is its name? Sir, his name is PTR arrow link. Name of that fellow is PTR arrow link. assume it as x. Assume it as x. Now he is pointing to this node, na? Sir, pointing to this node. Are he's touching here, here, anywhere it can touch. If not inside, that's enough. It's pointing to this node. Who is that fellow? PTR arrow link. What is we have assumed here? X. So x is pointing to here. X is pointing to here. Sir, x and PTR arrow link are same, na? Are hai. PTR arrow link are having an alias name in the form of x. Now you tell me, can you touch this blue part? Yes, sir. How? Sir, x arrow priv. X arrow priv. Substitute the value of x. Oh, acha. PTR arrow link arrow priv, na sir? PTR arrow link arrow priv. I will touch this blue one, guys. PTR arrow link arrow priv. What, sir? What to write here, guys? PTR arrow link arrow priv. Whose pointer name is this, sir? Blue one. Where he will point? Sir, to this node. That means the blue fellow will be updated. The blue guy will be updated. With what value, guys? Sir, with the value of the node that is pointed by temp. And what you will write to get that? Sir, very simple. PTR arrow link arrow priv is equal to temp. Then immediately what will happen? This blue fellow, the blue fellow now started 1 minute, guys. Sir, this blue fellow now started coming and pointing to this node. Oi, inside or outside? 100 to 100% outside, sir. Where is the question of inside? I'm accessing not the link part, I'm accessing the node. So where it will point? To this node. Who is pointing to this node, guys? Temp. This connection is ready. This connection is ready. You said na 4 connection will be there, sir. Till now, how many are ready? 2 connections are ready. Now can you update this black fellow? Yes. Why? Sir, remaining portion of the linked list already captured, na? Hence no issue. The remaining portion of the linked list is already captured, hence no problem. Now you tell me what to do, sir. Sir, the black fellow I will update. Where the black fellow will go? Sir, to 10. I will touch the black fellow. Sir, very simple. PTR arrow link. PTR arrow link is equal to. That is the black fellow now, guys. Yeah, he will be updated, sir. So that means this connection will be lost now. Yes, this connection will be lost. Okay, Bantika, watch the video and join in the next session. Tomorrow we will have the session. Okay, join tomorrow. Tomorrow we will have the session, so join tomorrow. Okay, now here what I will do, guys, to touch this part, PTR arrow link. Let's do that. This is PTR arrow link. Where it will point, guys? Sir, to the node. 1 minute, guys, 1 minute. Where it will point? Sir, it will point to the node that is pointed by temp. That is pointed by temp. Inside and outside. 100% outside. No. How many pointer have been adjusted till now? 3. How many are pending? 1. What is that 1? Before that, let me complete this line. PTR arrow link, check it out. PTR arrow link, where it is pointing now? To temp, sir. To temp. How many is pending? This one is pending, sir. This one is pending. What is the name of this fellow? Sir, temp arrow prev. Temp arrow prev. Go move. Achha, 1 minute. Move. Move. So this is temp arrow prev. This is temp arrow prev. But where the temp arrow prev will point, guys? Temp arrow prev, where it will point? Inside or outside? Definitely outside, sir. Outside means you are coming from here, you are coming from here, you are coming from here. Any direction you can come. Outside means, sir, this node is pointed by PTR. Outside means the node is pointed by PTR. So that means here which node's address we are going to give? 20. 20's address currently is there with whom? PTR. So what we are going to write here? Temp arrow prev is equal to PTR. Then which connection we are going to write here? Don't think PTR arrow link. Array, am I entering in the inside the box? No, no, guys. Now you see, every connection is ready now. Node is perfectly inserted at the 4th position. You said that. Super. Is my coding is okay? Seems it is okay, but it is having some issue, guys. Where is the issue? See, PTR arrow link arrow prev. What is PTR arrow link arrow prev? Sir, this is PTR. This is PTR arrow link. Remember, guys, that X and then this node pointer. That is PTR arrow link arrow prev. Where it may create problem for you. Have a look here. Where this fellow can create problem for you. When that fellow will create problem for you, observe. Suppose this is the condition of a linked list at any moment. How many nodes are there? How many nodes are there, guys? 5. What is the value here, sir? Null. You ask user, enter the position. User said POS is equal to 6. Any position you said, na? Item, some value 35. This is, you started coming from the beginning. What is that? Memory allocation, temp data item, etc., etc. Do that very fastly. Memory allocation, sir, for new node. Super. Who is pointing to this node? Temp. Its data part will get what value? 35. Give that. Give this 35. Currently pointed by whom? This node? Sir, temp. Currently pointed by temp. Then what to do? PTR is equal to start for loop rotation. Start it. PTR is equal to start, sir. Start it here. This is your PTR. How many movement is required? Sir, position -2. Position -2 means 4. Okay. First movement, second movement, third movement, fourth movement. Perfectly standing there. Next. Where is the problem? Temp arrow link is equal to PTR arrow link. What is PTR arrow link, guys? Null. This node will be inserted at 6th position, means at the end. So he will also get what value, guys? He will also get what value? This temp arrow link. Sir, he will get the value of PTR arrow link. That is null. That is what? Null. Up to this, no problem. Now you see, guys, where you will face the problem. What you are telling? PTR arrow link arrow priv. See this, how it is creating problem for you. How it is creating problem for you, this line. PTR arrow link arrow priv. Tell me, guys, PTR arrow link is what currently? PTR arrow link is currently what? Null. Then entire line becomes what? Null arrow priv. Can null have the priv part, guys? Do you think null have the priv part? Node can have priv part, link part. Can null have the priv part? Your program will suffer at runtime. Because syntactically everything is okay, your program will suffer at runtime. So that is why you are not allowed to write this line directly. You may get error at some cases. That is why you have to keep a checking here. What is that checking? If PTR arrow link not is equal to null, then do this. Now automatically this part will be stopped now. Now automatically this part will be stopped because PTR arrow link is equal to null. So don't do this. Myself is not going to get the runtime issue. So this is what is very, very important to write. Otherwise you may think, sir, every insertion is happening. Someone else try to insert at the end. He will suffer. He will suffer. Next and after that, where is the next fallacy in the coding? Where is the next fallacy in the coding? So if anyone give the insertion, if anyone enters the position as 1, or position as 1 means beginning only. Beginning code already you have now. How to insert at beginning code, that already you have. Just copy it from here. If POS is equal to 1, where is the code for insertion at beginning? POS is equal to 1 means insertion at beginning code. Copy the code from there. Which part will copy everything? No. Temp arrow data is equal to item already done. I will copy from here. I will just copy from here. Okay. Paste it here. Okay, na? Beginning part also included. Beginning part also included. Still there is a little bit problem in the coding. What is the code problem? Suppose, guys, you have this you have this condition here. Suppose you are having how many nodes? 5 nodes. Let us assume user enters 7 here. User enters 7 here. How many movement of PTR should have? POS -2, 5 movement, na sir? Let's do first, second, third, fourth. Then you said how long you will move? You said how long you will move? POS -2. That means 7 -2, 5 movement. How many movement I have made till now? Observe here. 1, 2, 3, 4. Another movement, na sir? Another movement. In that movement, what to do? In that movement, what to do? PTR is equal to PTR arrow link. PTR is equal to PTR arrow link. Currently PTR value is what? This. PTR arrow link value is what? Null. So PTR is equal to PTR arrow link. If it happens, what will happen? Sir, PTR will reaches to null. PTR will reaches to null. Once PTR will reaches to null, guys, now observe how this code will work. Temp arrow link is equal to PTR arrow link. Null arrow link. Again problem na? Again problem na? PTR reaches to null means you didn't get the position. You see here. In a linked list of 5 nodes, how can 7 position exist, boss? How can position 7 exist? Oh, that means when PTR reaches to null, that means it's an invalid position. So that is why here, after making the movement of PTR, keep a checking here. If PTR is equal to null, if PTR is equal to null, no point of continuing further because sir, that's invalid position. Printf invalid position. The position you entered is the invalid position. Return the control from here. Return the control from here, and before return, that temp memory allocation will be no use na. Free that memory. Free temp. Free temp. Is it the coding is done? Yes, coding is done. Just one more modification. What is that modification, sir? Suppose, for example, there is no node is there in the linked list, guys. You run the application, execute, compile and run. You run the application. Let me close the instances, guys. Execute, compile and run. Sir, directly I'm giving option number 3. At that time, where is start, guys? Sir, null. Remember that. I want to insert 15. Enter the position of insertion. Enter the position of insertion. If I give 1, no problem, it will be inserted. If I give 1, no problem, it will be inserted. But somehow I entered 2. No node is there, I inserted 2. Guys, if no node is there, how can be position 2 is true? Not possible, na? You started from here. Memory allocation done. Temp arrow data done. You check the position number 1. No, not yet. PTR is equal to start. PTR means what value, guys? Start value. Start is having what value? Null. Now what value you enter for position? 2. Now you see 2 minus 2. 2 minus 2. It's a 0. Let us assume instead of 2, sir. 1 minute, guys. With 2, it's not possible to show. 1 minute. Let me run one more time. Wait. DLL. Yes. Execute, compile and run. One more time. I give the option 3 directly. Some value 20. Position of insertion, I give 4. Now you see. Sir, control comes here. Inserted any numbers. Yeah. Sir, control comes here. New node created. Checking done. Item value inserted. Its position 1? No. Is the position value 1? No. Control is coming where? Line number 64. PTR is equal to start. Listen. Start is null. No node is there. Start is null. And what is the position value entered? 4. What is the position value I entered? 4. 4 minus 2 is what, guys? 2. 2 times loop will rotate na. First time PTR is equal to null, guys. Remember what is happening? Null arrow link. Null arrow link. Problem na. That's why see my program is also having the problem. My program is also having the problem. Check it out. 3, 10, 4. See suffering. Where is the working? Runtime issue na, sir. Null arrow link. How it will resolve the situation now? Problem na? Yes. How can we get rid of this? Sir, here add one more thing. ptr not is equal to null, then only I will move. Then automatically it will not be able to enter here because ptr is null. Now it will check here and will tell invalid position. Now definitely it will work now, sir. Yes, check it out. 3 guys, 10, 4, invalid position, sir. No node is there. How can you insert at position 4? Then my code should tell invalid position. Let's see. Super. Linked list appears again to work for it. Now you can give any option and anywhere. You can give now any option anywhere, it will work. Thank you guys. Tomorrow when we'll meet, we will go for double linked list, insertion at, and deletion from 3 different positions. So this is double linked list insert at any position. I will share the code. Your job is to run the code and test by giving any option at any stage. Are they working or not? If not, let me know tomorrow. 100 to 100% it will work because we understood every situation and then we bring it into the coding. It's not like arbitrarily I started from beginning and ending to the coding. No. Situation I bring in front of you and then only I write the code. Thank you guys.